Capacitance and capacitors. Capacitance is the ability of an object to store electric charge, while a capacitor is a device for storing electric charges in an electric field. The capacitance C is a constant for a given capacitor. The SI unit of the capacitance is the farad, represented by capital letter F. Capacitance is usually measured in microfarad, which is equal to 10 raised power minus 6 farad. The circuit symbol for a capacitor is as shown. Practical capacitors are of different types: variable capacitors and fixed capacitors. Capacitors are used in many household and electronic devices like 1. Electric fan, which help the fan motor to start and run smoothly. 2. Touchscreen phones, tablets, and computers. They are used to detect finger contact by sensing change in capacitance. 3. Computers. Capacitors are used for smooth power supply and storing information in memory components. 4. Washing machines. They provide the necessary phase shift to start motors and varying speed. 5. Microwave ovens. They create high voltage needed to heat food. 6. Air conditioner and refrigerator. They assist in starting the compressor motor and stabilizing the voltage. 7. Lightning LED. Capacitors are used to filter voltage spikes and stabilize current to extend the bulb life. 8. Audio and video equipment. They are used to filter and shape electrical signals for clearer sound and images. 9. Other machines. Dishwashers, dryers, pumps. They help to start and regulate motor performance. How a capacitor works. A capacitor consists of two conductive plates, usually made of metals, separated by an insulating material called a dielectric. When voltage source, such as a battery or an alternating power supply, is connected to the capacitor, positive charges accumulate on one plate, while negative charges, electrons, gather on the other. The dielectric prevents the electrons from passing through, so they remain on their respective plates. This creates a potential difference voltage between the plates and stores energy in the electric field between them. When the capacitor is later connected to a circuit, the stored energy can be released. Factors affecting capacitance. The capacitance C of a capacitor depends on three main factors. 1. Type of dielectric material. The dielectric is the insulating material between the plates. The capacitance increases with the permittivity of the dielectric. A material with higher permittivity can establish a stronger electric field, allowing the capacitor to store more charge for a given voltage. The permittivity of free space in vacuum is a constant, and other materials have relative permittivity. 2. The area of the plate A. The larger the surface area of the plate, the more charge that can be stored. Therefore, capacitance is directly proportional to the area of the plate. The distance between the plates D. The smaller the separation between the plate, the stronger the electric field for a given voltage. Therefore, capacitance is inversely proportional to the distance between the plates. These three factors are related by the equation C is equal to epsilon A over D, where all the symbols have their usual meaning.